Hi everyone, today we're going to be modeling and solving two-step equations with variables on both sides of the equal sign. We're going to be doing this in an app called Braining Camp. So essentially it's just algebra tiles online. So to do this, we're going to use these green blocks with an x in them to represent x. That's our variable. So every green block represents one x, and every yellow square block represents 1. The equation we're going to be starting with is 3x plus 2 is equal to 11. So that since our variable is 3x, that means we're going to end up needing 3 of those long green bars. We're going to need 2 of those yellow squares on the left and then 11 of those yellow squares on the right. So I'm just repositioning the equation so that the equal sign is on the line, because remember that we draw the Great Wall along the equal sign so that we can separate the left and the right side of the equation. So I'm just going to go ahead and I'm going to take 3 of these green bars and I'm going to put them on the left side of the equal sign. So that's 1x, 2x, 3x. So next I'm going to put my plus 2, and remember these yellow squares represent 1, so that's 1, 2. So you can check it here at the bottom. Everything I put on the mat corresponds to this equation here at the bottom. So far the left side of the equation that we're starting with is looking like the equation on the bottom, so now we need to make the right side match. So on the right side we have 11, so that means we're going to need 11 of these yellow squares. So I'm just going to drag 11 of them over. If you click on the yellow squares, it'll just add them to the mat automatically instead of having to drag them over and over again. I'm gonna go ahead and copy and paste those and add one more. So now I have 11 yellow squares on the right, and that gives us our equation 3x plus 2 equals 11 modeled with algebra tiles. So now that we've modeled the equation, what we need to do is we're going to solve it. So we can't just take these 2 yellow squares on the left and then drag them over to the right side, because it wouldn't be balanced that way. We want to get all of our variables on one side of the equation and all of our constants on the other side. But we need to do it in a way that's balanced. So remember, to do that, we're going to have to subtract. Since these 2 yellow squares each represent positive 1, I'm going to drag 2 red squares. Those each represent negative 1. So for every yellow square, I need a red square. And since I now have minus 2 on the left, I need minus 2 on the right as well. Everything we do on one side, we do on the other side. So I have 2 red squares on the left and 2 red squares on the right. So each one of these red squares cancels out a yellow square. So you can see here at the left we have plus 2 minus 2. That's called a zero sum. So I'm going to go ahead and cancel out the plus 1 and minus 1. That leaves us with 3x equals 11 minus 2. So we're going to go ahead and we can't have red and yellow on the same side. So that cancels that out, and now we have 3x is equal to 9. Now we've accomplished the first step. We have our x's on the left side of the equal sign, and we have our 1's on the right side. Our variables are on the left, our constants are on the right. They're separated, and that's exactly what we want. That's step 1. Step 2 for a two-step equation is we're going to need to find out what 1x is equal to. Right now we have 3x is equal to 9, but what is 1x equal to? So down here on the bottom right, there's these little bars. Those represent rows. So since our coefficient, the number in front of x, is 3, we're going to need 3 rows. So now we have it divided into 3 rows because we have 3x. So I'm going to put 1x into each row, and then I'm going to take these 1's and I'm going to divide those equally into each row. That correctly, then you'll be left with something that looks like this. So each row has 1x on the left and 3 on the right. So my final answer, you you just look at one of these rows and your final answer is going to be x is equal to 3.